Hi guys, I will be starting with the last lecture of the session, that is C++11 New Features Part 8. So guys, I will be covering the feature which is very important, and that is multi-threading. So guys, as I have described in my previous session of the introduction, that I have divided this whole session of C++11 New Features into different parts, from Part 1 to Part 8, wherein I have covered different small features in different parts, guys. So now we will be ending the complete features of the C++11 in this part 8, guys. So I will be teaching you multi-threading, guys, and guys, these are the summary of the features which I have covered in the previous part. So if you have not gone through it, guys, please go through it. So let me repeat it for you. So this is I have covered auto, have covered initializer list, uniform initialization, null pointers, static assert, overlapping and delegating constructors, converting constructors and explicit, override and final, default and delete, const, expr and symbolic constant, variable size, lambda functions, enum classes, std, array container. So guys, I have covered all these C++11 new features in the earlier part, guys. So if you have not gone through it, please go through it actually. And in this last part, that is part 8, I will be covering multi-threading, guys. So let's see what is multi-threading in C++11, guys. So guys, multi-threading, the new feature which is added by C++11 actually, using different multi-threading function, we will see it. So guys, basically we know multi-threading means what? It is used, guys, for the concurrent execution of the program. So if we want that our program executes various conditions within the small time, guys, then multi-threading is required. So guys, concurrent execution of the program takes place in that case. So guys, prior to C++11 actually, for multi-threading we was using POSIX threads or pthread library in C, guys. But what is the disadvantage using this POSIX thread or pthread, guys? The disadvantage is, guys, if you have written the code, multi-threading code, that is using POSIX or pthread in C, guys, in that case we cannot execute that code in any other language, guys. So it is not portable actually once if we have written it in the C. So the problem with that library is the code which is not portable means if we write the code in C, then we cannot execute that code, guys, in any other language. So it is not portable actually in any other language. Once we write the code in C, it will be we cannot execute it in any other language, guys. So it is not portable in that sense, and that is the reason actually C++11 have introduced multi-threading by using std scope resolution thread, guys. So this problem will not occur actually, that is even if we write a code in C, actually we can execute it in any other language. So guys, so all the thread functions will be included in the thread header file for that. So std thread is a thread class that we present single thread in C++. So guys, these are all note down. You can please make a note actually regarding these. These are the points which I've also listed actually, so that you can refer it later. So guys, to start a thread, we simply create a new thread object and pass to the object to the calling constructor. So this is how we create. To create a thread, we have to create a thread object actually, and as an argument, we will be passing it to the pass to the object to the calling constructor. We will see, guys, how to achieve it actually, how to create an object, how to pass it to the calling constructor. We will see one by one. These are only the node points. So guys, this is how we represent actually, that is we will here std scope resolution thread is used. We are creating the object name thread underscore object, and we are passing argument actually as callable. So guys, these callable are of 3 types actually. So that is a function we can create actually the object, and this callable is of three types. So that is, the first one is a function pointer, the second one is function object, the third one is lambda expression. So we will see guys how to create the thread object using these three callables actually one by one guys. So let's see launching the thread using this function pointer. That is the first one guys. So guys, in this we create the thread object. Okay, that thread object contains two parameters. The first parameter will be the name of the function. Since it is using function pointer, that means we are passing the function and the input arguments to it. So guys, we have to create a thread object, and in that we will pass the first argument as the name of the function, and the second will pass the arguments which we want to pass it to that function. So since it's a function pointer, therefore the first argument will be the function name, second argument will be the arguments which we want to pass to that function. So let's see guys how to achieve it using the function pointer, how to create a thread in case of C++11. So guys, this is a main function. So guys, as I told you, when you compile your program, the execution of your program always starts from the main function. So whatever line of instructions you have written inside this main function, it will be executed line by line in sequence manner. So guys, this first instruction is there, that is, we are creating an object of std scope resolution thread. We are creating the object by the name thread underscore obj, and we are passing two arguments in it. So guys, the first argument, since it's using a function pointer, as I told you, first will be the name of the function, second will be params. So guys, this function actually, that means this, here we have defined the function, and this parents, whatever argument which we pass will be passed as an argument here like parameter, and we are simply displaying the message like inside the function. So this is the first way in order how to create a thread object actually using function pointer by passing the name of the function. This is the name of the function, and input arguments. This is the input argument which will be passed here. We can use this input argument inside this block. Anything we can do, we can display the message. So guys, this is first representation how create a thread object using function pointer. Let's see how to create a thread object using the lambda expression in the second way guys. So guys, again we are having the main function wherein the execution of your program starts. So we are creating an object of the thread, std scope resolution thread. We are creating the thread object by the name thread underscore object, and we are passing two arguments to it. So guys, first, since it's using lambda expression, we have already seen in what is a lambda expression feature which C++11 provide in the earlier part guys. If you have not gone through it, please go through it actually guys. So in lambda function, I've told you guys, it's represented always by square bracket open and close actually, and this is the input argument, this is the block actually. So in this thread object which we created, thread object, we are passing the first argument as a lambda expression, and the second is the input argument, so that will be passed as here. And we can either we can use this params or we can simply display the message. So this is how we go guys. So guys, the third representation of creating the object using the function object is, again we are having the main function. We are creating the object of this thread by the name thread underscore object. We are passing the first argument as, guys, this is the name of the class actually, and these are the parameters. So guys, this name of the class here, this is the name of the class, and the parameter, the second argument will be passed like this in this operator guys, inside this function. So this message will be printed. So guys, this is the third way actually using the function object how to create a thread. So guys, we will see some concept of the threads actually to understand more better actually in case of C++11. So guys, waiting for threads to finish. So guys, when thread comes, how your execution of your program starts, how what will happen, I will describe you in detail guys. So guys, whenever there is a program actually, the main function wherein you are having the main function. So guys, your program actually, the whole program, that for that actually the main thread will take the responsibility to execute your whole program. So then once you create a thread inside that main program, then that is called as a subthread guys. So you should always ensure actually that your main program that will not terminate before completing the task which will be which your subthreads are assigned to. So if you are creating 2-3 threads in your main program, so your main program should not terminate till 2-3 threads which you have created completes their task actually. So let's see actually, I've described in detail here guys, so that later on you can also refer. So it's a note down guys. So as we know that when a program is running on the RAM, then the operating system allocates one thread for that program that we call as a main thread. So guys, I told you that for your program actually, so for your program execution, the operating system will allocate the main thread to execute your program when once it is running on the RAM guys. So your program is started from the main thread guys. So it is responsibility of that thread, that is main thread, to execute all the code which is written inside that main thread, and when that all the functionality is executed properly, then give the value 0 to the operating system. As successfully executes, the operating system will release all the resources which was given to that thread. So guys, it is saying that when your program executes on the RAM, then the operating system will allocate a main thread to your program. So you should make sure that your main thread actually, that the program don't terminate until and unless there are many threads which you have created completes their task actually. Once your multi-threads, if you have created many threads actually, and different tasks will be done by these threads actually, once they are completed with their task, that is in that case actually, then only it is supposed to give return 0 actually to the operating system to say that now the whole program is executed successfully, because every task which was assigned to different threads, they have completed their task actually. Now the program operating system actually now it is free to terminate actually the main program, the main thread. So guys, therefore it is responsibility of the main thread actually to ensure that all the subthreads which it has created actually are supposed to complete their task, and then only it will return 0 as telling the operating system the operation is done successful. Now it is free to release the resources which was assigned to the thread guys. So this is how the process takes place guys. Like the main thread will ensure all the subthreads completes its task actually, and then it is supposed to send 0 actually, so that the operating system will release the resources which was allocated to the thread. So guys, these are all the note down guys. So guys, to take care that we have to first complete the user defined thread execution after the main thread will complete. The same thing guys, we have to ensure that subthreads complete their task before the main thread goes to termination guys. So guys, how to achieve this feature actually, that all subthreads completes its task actually, then only the main thread can go to termination by using this function guys, that is std scope resolution join function. So we will see how this is achieved. So guys, this is a snippet of the code to explain just how to achieve. This is the main function. You know, always when you compile your code, in the execution of your program starts from this main function, and it will execute line by line sequentially these instructions. So guys, you are creating an object actually, that is std scope resolution thread, actually creating object by the name t1, and then this is a callable. So you know that callable can be like using function pointer. We have seen using lambda expression, using the function object. So we have seen in earlier cases how to achieve this. So guys, here we are creating a thread object. So guys, you know this main function is there, therefore main thread will be assigned to execute this whole program. Then guys, inside this we are creating one more thread actually, subthread. So guys, then we are by the name t1, so and we are doing t1.join. So what does it mean? So it is saying operating system that till t1 don't execute its whole code actually, whole task, do not terminate this main thread. So it means that since t1 is a subthread guys, and then callable is there, so your function will be called actually depending actually if it is a lambda expression, if it's a function object, or if it's a function pointer. So control will go there and actually execute the block. So guys, it is saying if you use T1.join, it is saying operating system that don't terminate this main thread actually till T1 gets completed. So therefore, this T1.join is used, means till T1 is not completed, don't execute this main thread. It means that, and then return 0. So I hope guys you understood. So this is a meaning with what all I told you guys from the previous example. Yeah. So the main thread will created by the operating system that is in main. So by using T1.join, we should set to operating system as don't terminate the main thread until the execution of T1. So what I told you guys, T1.join means you are creating this subthread and you are telling operating system till this T1 is not completing its task, don't terminate this main thread. So guys, this is how the process takes place. So this two concept is there, which is very much important in case of C++ 11 multi-threading guys, that is STD scope resolution future and STD scope resolution promise. We will see what it is and what is its main purpose. So guys, if we created the threads in that, suppose one thread is sending the result to another thread, and how to achieve guys. So suppose we want a communication from one thread to another thread, it means simply the same thing. So suppose we have to calculate a sum and then we need to return. So guys, we will see how to achieve this communication from one thread to another, that is how to share the data among these threads using the pointers. So there are two ways actually. The first way, we have the sharing the data among the threads using the pointers. So let's see. So guys, first is that, so the first way actually to achieve the communication between two threads actually, that is one is doing the operation of sum, and then one have to return this result to the another thread. How to achieve this communication? One is sharing the data among the threads using the pointers. So how to achieve? Pass the pointer to the new thread guys. First thread will do his job to calculate the sum, then it will till that main thread will keep ideal, means we can use the mutex condition variable for that. So guys, is that first the subthread will complete the task of doing the operation of sum actually, and it will. So for that we can use actually the mutex and condition variable actually, so that the main thread will not terminate actually. So that till the subthread completes the operation of sum actually, and once the subthread completes the operation of sum, and in that case it calculates the results actually of the sum, then the subthread can send the signal to the main thread. So guys, we can use simply the mutex and condition variable to achieve this. That is, we want the sum operation to be done by the subthread, and we want actually till that main thread should keep a hold actually till the subthread completes the operation of sum. So we can do using the mutex and condition variable. So once the subthread completes the sum operation, it will send signal actually to the main thread saying that it has completed, it has calculated the result of the sum. So this is the way guys. So once the signal is coming to the main thread, it will wake up and fetch the data from that pointer. So this is how guys. So first we have to pass the pointer to the new thread that is the subthread guys, and first thread will do his job to calculate that. That subthread will do the job of calculating the sum. Until that time guys, main thread will keep on hold, since we will be using mutex and condition variable for that. And guys, once the subthread calculate the result, it will set the result in this pointer actually, which was passed to it actually, and send the signal to the main thread guys. So once the signal is coming to the main thread, then it will wake up and fetch the data from that pointer. So this is how we achieve. We will pass the pointer to the subthread, wherein subthread will complete its operation of sum and will calculate the result and pass this result to the pointer, and it will also send a signal to the main thread saying it is done. So once the main thread then will wake up actually and receive the result actually using the pointer. And this is how this process takes place. So this is the way actually to achieve the communication. So guys, what about actually if we want to return the sum, difference, multiplication, division, many operations we need to do actually. So this was a simple way using this mutex and condition variable, wherein we wanted the subthread to calculate, to do the sum operation and to return the result of the sum to the main thread actually. Until that time, when the subthread performs operation of sum, till that time main thread should keep on hold. Once the subthread completes its sum operation and return the result, then only main thread should wake up and collect the result from this pointer which was passed to the subthread. So this was only for returning sum, actually sum operation. But what about if we want to do many complicated many operations like difference, multiplication, division, sum, all these things. So for that, guys, comes into picture actually this concept, that is STD, scope resolution, future and promise. Let's see one by one what it is. So guys, again, this is a concept, so please understand it. If you can go 2-3 times to understand it more better. I have made the note down for that, guys. So STD future is a class template and its object stores in the future value. So the name itself, you can understand that STD, scope resolution, future is a class template, guys, and its object store. So its object will store the future value. So it will not have initially its value set. Its value will be set in the future. That is the reason its name is given in this manner, guys. So actually the future object internally stores a value that will be assigned in future, and it also provides a mechanism to access that value using the get member function. So this is a template actually, and its value will be set in future, and also it is having the function actually, that is the get member function is there. So guys, but if somebody tries to access this value actually, so if somebody initially only tries to access the value calling the get function for this future actually, then guys, in that case, since its value is not set initially actually, in that case the get function will block till the value is not available. So guys, always remember this STD future is a class template and its value will be set in the future. It is having the member function as get, and if somebody tries to call this get member function in order to achieve this value earlier only, at the earlier stage, at the stage where this value is not set, in that case this get function will be blocked till this value in the future is set, guys. So this is the concept. Another concept, that is STD promise. So guys, I'll explain it more clearly with the program down, so don't worry, this is concept to explain you earlier, and then we will cover the program. So guys, STD promise is also a class template and its object promises to set the value in future. So guys, we have seen STD future is the value whose value will be set in the future actually, but STD promise is also the template, and this STD promise will set the value actually in the future. So this STD promise will set value of this in the future. So each STD promise object has an associated future object. You can see how connectivity is there. Each STD promise object has an associated STD future object that will give the value once set by the promise. So the role of the STD scope resolution promise object is to set this value actually. So guys, I'll explain you in the program more clearly. So STD promise object shares the data with its associated STD future object. So let's see what all these things. So I hope you understood the concept at least. STD future object is a class template actually, guys, and its value STD future value will be set in future, and it is having member function as get, and who will set the value? STD promise object will set the value. Let's see, guys, how to achieve it. So we are having the main function. You know that when you compile your program, the execution of program starts from this main function, guys. So we are creating these are the class templates. We are creating an object of this promise actually, and also the future. So guys, we are creating the object of the promise and we are creating the object of the future. So in this, how to get the future object, since we know that promise object in future will set its value, therefore there is a function, member function, that is get underscore future in this promise object, which will give the value of future object. So this value is not set actually, this is just we are creating an object initially. So guys, this is a promise object, this is a future object, and we are calling the member function of the promise object, that is get future, because we know that promise object in future will set its value. So we are calling this function. So till this time it's not filled actually, and later on it will be filled, guys. This is just to create an object. So guys, then we are creating a thread, std thread actually. Since we are using namespace here, that is the reason we are not mentioning std scope resolution. If we mention using namespace std, so then we are creating the object of thread by the name th. We are passing the initializer, that is the name of the function, and then we are passing the argument to it, that is underscore promise object. So this we are passing this address of this. So this initializer, we have done the implementation of this function, that is initializer. So we are passing this argument actually here, guys. Ampersand this, we are passing this reference here. So guys, in this case, we are displaying the message simply inside the thread, and this promise object we are setting the value. So we know that this promise object role is to set the value of the future object. So we are setting it by 35, and then guys, here we are printing the object by using this object. So by calling the get function, actually we are printing the future object. So we are doing th.join because we don't want actually this main thread to terminate till this th, that is a thread, this thread completes its execution. We don't want the main thread to terminate. That is the reason we have to call th.join, which I have specified earlier. So guys, these are the concepts I hope you got. And by the let me explain your concept. In first, we created the promise object. So here we are creating the promise object, guys. So as we know that as of now there is no any value in this promise object. We know that there is no value here, but it gives a promise that somebody will surely set the value in it, and that value we can access through std future object. So promise object, because the name itself is saying that it is promising that later on it will be setting the value of the future object. So guys, also now suppose thread1 created this promise object, passed it to the thread2 object. Now how thread1 can know that thread2 is going to set the value in this promise object? So guys, we are creating this promise object here in the main thread, that is thread1, and we are creating the thread object here, and we are passing the ampersand address of this promise object, guys. So guys, how we will know that this function will set this promise object actually? So guys, for that actually we have already keep a reference actually of the future object by this promise object. So since we are passing this address of the promise object in this function, still we have getting the future object by this promise object earlier. Before passing this promise object address to this function initializer, before only we are calling this get future actually. That is, we have collected the future object from this promise object, guys. So guys, so that later on actually when somebody will try to access actually this future object by calling the get function, if this value is not set actually, then as in we have seen in the concepts which I have described, get function will be blocked actually if this future object is not set. So guys, I hope you are understanding. What we are doing is we are creating a promise object, we are creating a future object. So before passing the address of the promise object to this function, we don't know whether this function will set the value of this future object, but we are collecting, so that is the reason we are getting the future object from the promise object initially only. Before passing its address, we are getting the future object from this promise object, and later on we will be calling this get function through this future object. So if this will be getting blocked, that means still its value is not set actually in this function, and if this value is not blocked, that means yes, this function have set the value of this future object. So guys, in this initializer we are setting the value. So this is how guys the process takes place. You can go 2-3 times to understand more clearly, guys. So guys, we know that every promise associated is having the associated future object through which other can fetch. So thread1 will create promise object, and fetch the future object from it before passing. So what I told you that before passing this address of promise object, we are retrieving the future object from this promise object, so that if this initializer function is setting its value later on, if we call the get function, if it is blocked, that means this future object is not set. If it is not blocked, that means its future object is set by this initializer function, guys. So guys, this is just an explanation. Actually, you can see that it's lots of explanations there. I have given a note down for your understanding, guys, so that if I'm explaining you now, later on you can also read it once actually, and you can go through it. So I hope you understood how to achieve all these things. There is a main function. Let me pardon in short. We are creating a promise object. Promise object means the name itself is saying it is promising that it will set the value of the future object, and this is a future object, and by this promise object get underscore future function, we'll get this future object. So guys, we are creating the thread here. We are passing first argument as a function name, second argument we are passing parameter, that is ampersand of this. So guys, before passing this address of promise object, we are retrieving future object from this promise object by calling get underscore future, so that later on, since we are calling get function, we will be able to call the get function actually through this future object. So once we create a thread actually, this initializer function, wherein here we are passing the argument of the address of this promise object, and we are setting the value actually of the future object here. So guys, if this future object, when we call the get function, if it is blocked, that means still the value of the future object is not set. If it is not blocked, that means this initializer function, that is this function, have set this value, that is have called this instruction actually, and then we will get the value. So this is how guys we achieve. So guys, in this case, using the future object, promise object, we can do multi operations like multiplication, division, subtraction, all these things we can achieve, guys. So guys, I'm done with this multi-threading in this last part, that is part 8 actually. So now guys, I'm done with the C++ 11 new features completely. So guys, I hope you enjoyed, you understood. If any queries, please let me know, please post it, guys. So guys, I'm done for the C++ 11 new features. Thank you guys, thanks a lot.